We use numbers to describe pretty much everything, right? But have you ever stopped to think if a number, all by itself, is always enough to tell the whole story? Because sometimes a single number is all you need, but other times it leaves out the most important part. So imagine this. You're a pilot, and the control tower radios in, fly at 500 miles per hour. Okay, great. That's fast. But which way? North, south, straight up? Without a direction, that speed is kind of useless if you're trying to get from, say, London to New York. And that simple problem is really at the heart of what we're talking about today. You see, in physics, this whole idea is such a big deal that we have two totally different ways to describe things. And it all boils down to one simple question. Does direction matter? First up, we've got what are called scalar quantities. Now, these are the simple ones. They just tell you how much of something there is. Its magnitude, its size. You get a number and a unit, like 10 kilograms, and boom, you have the complete picture. All that matters is the size. And then, on the flip side, we have vector quantities. These are the ones that need a little more detail. They've got a magnitude, the how much, but they also have a direction, the which way. And you absolutely have to have both pieces of information for it to make sense. Seeing them side by side like this makes it all click, doesn't it? A scalar is just a number. It has size. But a vector? Well, a vector is like a number with an arrow attached. It's not just 10. It's 10 pointing that way. That one little addition, direction, changes everything. All right, let's dig into some everyday examples of scalars. I guarantee you use these all the time without even realizing it. These are the quantities that are nice and straightforward. They just give you the magnitude. Just think about it. Distance, I ran 5 kilometers. Done. Speed, my car was going 60 miles per hour. Simple. Time, this explainer is about 5 minutes long. Mass, this apple is 100 grams. Same for energy or temperature, like a cup of coffee is 80 degrees Celsius. See? No direction needed for any of them. Okay, now let's switch gears and move on to the vectors. This is where just saying how much leaves the story totally incomplete. For these, we absolutely, positively have to know which way. Just look at this list. Force, you can't just push something, you have to push it in a direction. Weight is a type of force that is always pulling you downwards towards the center of the earth. And velocity, hey, that's our airplane example. It's not just speed, it's speed in a specific direction. The same goes for things like acceleration and momentum. Direction is literally part of their identity. So here's where it gets really cool. What happens when you have more than one vector acting on the same object? You can't just add them up like regular numbers because you have to deal with the fact that they might be pulling in completely different directions. Let's go back to that boat. The engine is pushing it forward with a certain velocity. That's one vector. But at the same time, there's a river current pushing it sideways. That's a second vector. So the boat doesn't just go forward, and it doesn't just go sideways. Where does it actually end up going? To figure that out, we can actually just draw it out. It's a method called tip to tail. First, we draw an arrow showing the forward motion from the engine. Then, starting right from the tip of that first arrow, we draw a second arrow for the sideways push from the current. And now for the final step. You just draw a brand new line from the very start of the first arrow to the tip of the second arrow. This new vector has a special name. It's called the resultant. And that is what shows you the boat's actual path and speed. It's the combined effect of the engine and the current. So, what's the big takeaway here? Well, it's that scalars can tell you part of the story, but vectors tell the whole story. From flying a plane to just understanding why things fall down, some things in our universe just can't be fully understood without knowing which way they're headed. So, I'll leave you with this little challenge. The next time you push a door open, or feel the wind blowing on your face, or even just walk to the store, stop and think about it. You are literally surrounded by vectors, so where in your daily life can you spot one in action?